Okay, let's do a first example of a triple integral. We're going to find the triple integral of x over a region D. D is going to be the region, the solid that's bounded below by the paraboloid z equals x squared plus 3y squared, and above by the paraboloid z equals 4 minus x squared minus y squared. So these are two bowls. We have the bowl opening upward and we have a bowl opening downward, and there's a region trapped between them, and that is our region of integration. We're going to limit that to just the first octant, just the points where x, y, z are all positive. So that's going to be our region. It's the shaded region here, but only the first octant portion of that shaded region. What we want to do here is just set up the integral. Not going to go through all of the integration steps, but just set it up. We're comfortable now with integrating things. It's really the setup that's new for these triple integrals. So for the triple integral, we want to integrate in z first. So we will have a double integral after we integrate in z. We'll have a double integral in x and y. And the integral in z goes from z equals x squared plus 3y squared down below up to 4 minus x squared minus y squared up above. The function is x, the integral is in z, and then we have remaining, after we integrate in z, we have this double integral. We have a double integral over a region R in the xy plane, and there's the dA for a double integral. So we know how to integrate x with respect to z. That's just x times z. We evaluated at the endpoints, and we're down to a double integral. So we've got the z part. We need to figure out the double integral part. To figure out the double integral part, we need to know what the region is for the integration. So let's figure that out. Okay, we've done the z portion of our triple integral. We've got that taken care of. And now we're left with a double integral to handle on the xy plane. Once we've integrated out z, we're left with x and y. So for the double integral, we need to know the region of integration. The region is this region down here in the xy plane. It's kind of a shadow of this solid down onto the xy plane. To find it, we look for the intersection of our upward opening bowl and our downward opening bowl. And we find the intersection by setting the z values equal to each other. So we have 4 minus x squared minus y squared equals x squared plus 3y squared, which, put this on the other side, you have 2x squared plus 4y squared equals 4, or x squared plus 2y squared equals 2, and that is an ellipse. So we've got an ellipse as the shape down in the xy plane. I can sketch that ellipse. Let me sketch that ellipse up here. X, Y, and the ellipse looks something like this up here, and that's a region, or that point there is the square root of 2 comma 0, and this point right here is 0 comma 1, and that is our region R. So that's a region for a double integral, and now we have to think about how we'd like that double integral to go. Do we want to do that x first? Do we want to do it y first? In this case, with this region, we could do it either way. It could be x first, or it could be y first. So I'm going to set it up x first. In the end, what we have is this z going from x squared plus 3y squared up to 4 minus x squared minus y squared, the function x, dz. And then I'm going to do the x integral next. And over here, I have x, if I'm doing this x first, then I have x going from 0 on the left to this point on the right. And it's coming from this ellipse, x squared plus 2y squared equals 2. So if I solve that for x, that is x equals the square root of 2 minus 2y squared. So the square root of 2 minus 2y squared as my upper endpoint for the x integral. Finally, I have the y integral. And the y integral, if I'm thinking of x first, the first one of these slabs that I would draw in x would be down at y equals 0. And the last would be up here at y equals 1. So we finally have the full triple integral set up. Now it's a question of integrating and plugging in a lot of messy endpoints of integration, but we've done the setup for the triple integral. We could have done it the double, we could have done x first or y first. We chose x first. Everything else falls into place after that. So.